Here we see two force vectors. Okay, again we're given the components. The x component and y components of the first force vector are 60 newtons and negative 90 newtons. The x and y components of the second are negative 105 and 35 newtons. The situation is something like this. The first vector is going to be off in this direction, the second vector in this direction. And when we put the two together, we get some resultant vector. And that's going to be what we call F1 plus F2, the sum of the two vector forces. That's the vector sum of the two forces, and we call that the resultant force, and I'm going to use R for the resultant force. This method of adding the vectors, where we draw both of them with their initial points at the origin, so each vector moves out from the origin in the appropriate direction and with the appropriate magnitude. When we do that, if we draw a parallelogram where these two vectors form the two sides of the parallelogram, and we complete the other two sides, this side being parallel to this one, this side parallel to this one, then the vector that goes from the initial point to the far corner of the parallelogram is going to be the resultant vector. Okay? So if we go from here to here along this parallelogram, we get the resultant force vector. Now that's all well and good, but how do we do that? Well, we have to do that by the components. Now in this case we're given the components. So to get the x component of the resultant vector, we add the x component to the two vectors. If we're pulling this way with 60 newtons and this way with 105 newtons, the net is 45 newtons in this direction. So we have a force of negative 45 newtons in the x direction. In the y direction, we're pulling down with a force of 90 newtons, up with a force of 35 newtons. The resultant is 55 newtons down. Okay, so we have a resultant vector now that's 45 newtons in the x direction, in the negative x direction, 55 newtons in the negative y direction. So the components are negative 45 newtons and negative 55 newtons. Now that we have the components of the resultant vector, we just go through the same procedure that we're used to, and we find the magnitude by using the square root of the sum of the squared components. And I haven't even gone through the details of that. We plug 45 newtons in here, 55 here, square them, they both become positive, add them up and take the square root, we get 71 newtons. The angle is going to be the inverse tangent of the y over the x plus 180 degrees. Again, adding the 180 degrees because the x component is negative. And that's going to give us 51 degrees plus 180 degrees, or 231 degrees. And that's going to be the angle. So that the net result of these two forces is 71 newtons and an angle of 231 degrees. And that makes sense in terms of the picture.